Hello students, welcome back to this lecture series of M.Sc. Part 1 Mathematical Methods in Physics. Okay, so today we are going to discuss property of Legendre polynomials. So first property is Pn, the function of minus x is equal to minus 1 power n into Pnx. Okay, so this property we are going to prove. First one, that is Pn minus the function of minus x is equal to minus 1 power n into Pn, the function of x. Okay, so here I am consider x is equal to or x prime is equal to minus x. Okay, so this x prime is equal to minus x. If I so if I differentiate this with respect to the x, so it is dx prime dx is equal to minus 1. Okay, so now if I consider d by dx, these things we can write in the term of x like this, in the term of the x prime. So we can write dx prime divided by dx into d by dx prime. Okay, so here dx prime by dx we replace with the minus 1. Okay, so this thing is equal to minus 1 into d by dx prime. Okay, so this is for the here power. If we power consider, so power of this d, that is 1, and for the n power or second power, we can write like this, d square by dx square, we can write d by dx into d by dx. Okay, so this d by dx is equal to minus 1 into d by dx prime, so it is minus 1 into d by dx prime into minus 1 into d by dx primes. Okay, so these things minus 1 power 2 d square by dx prime square. Okay, this is for the d square by the dx square. Now if I write for the d cube by dx cube is equal to minus 1, or in this term if I write, so it is d square by dx square into d by dx. Okay, so this is equal to minus 1 power cube d cube by dx prime cube. Okay, so like this we can write for the n terms. So it is d power n by dx power n is equal to minus 1 power n into d power n by dx prime power n. Okay, so this is about the d power n by the dx power n. Now we know the Rodriguez formula, that is Pn is equal to 1 by 2 power n into n factorials into dn by dx power n into x square minus 1 power n bracket power n. So this is a Rodriguez formula we defined with the Pn, and that is a function of x. So here we can d power n by the dx power n we can replace with this thing. So it is Pn is equal to, or Pn, which is function of x, is equal to 1 by 2 power n into n factorials, and this d power n by dx power n we replace with this thing. So it is minus 1 power n d power n by dx prime power n into x square minus 1 power n. So here this x we replace with the minus x. Okay, so it is Pn minus x is equal to 1 by 2 power n into n factorials minus 1 power n into d power n by d right here. So Pn minus x is equal to 1 by 2 power n into n factorials and minus or d power n by dx minus x prime. Okay, here is a this x primes, actually we replace with the x with the minus x prime. Okay, and the x with x prime with the x, that's it. Okay, so that's why here we can write dx square, okay, and into it is a minus 1 power n minus 1 power n into d power n by dx power n into x square minus 1 power n. Okay, so from this we can write 1 or this minus 1 power n into 1 by 2 power n into n factorials, and the d power n by dx power n into x square minus 1 power n. Okay, so this is first property, that is Pn is a function of minus x. Okay, so this is the first property of this Legendre polynomials. Now second property, that is n plus 2 into Pn plus 1, which is function of x, is equal to 2n plus 1 into x into Pn, which is function of x, minus n into Pn minus x. So this second property is n plus 1 Pn plus 1 into function of x is equal to 2n plus 1 into x Pn function of x minus n into Pn minus n. Okay, this is function of x. So here we are going to consider the generating functions of the Legendre polynomial. So we know the generating functions, that is g is a function of x and t, two variables, is equal to 1 minus 2xt plus t square bracket power minus half. Okay, this is a generative function, and you can also write is equal to summations over n is equal to 0 to infinity Pn is function of x into t power n. Okay, so this Pn is a Legendre polynomials. So now if I differentiate these things with respect to the t, these generating functions, so here minus half into 1 minus 2xt plus t square into minus 2t, sorry, with respect to t, so it is minus 2x plus 2t. Okay, and here minus 3 by 2. Okay, so when we differentiate with respect to the t, so minus 3 by 2 plus minus 1 will be added here, and is equal to summations n is equal to 0 to infinity Pn, which is function of x into n into t power n minus 1. Okay, so from this bracket, if I take out the common, that is minus and the 2, then this minus and the half will be cancelled out, and these things we can write t minus x. Okay, we from here we take out the minus is common, and this bracket we can write 1 minus 2xt plus t square (1 minus 2xt plus t square) bracket power half minus half divided by 1 minus 2xt plus t square. Okay, here is the power of this bracket is 1, so is equal to summations over n is equal to 0 to infinity Pn is a function of x into n into t power n minus 1. Okay, So this 1 minus 2xt plus t square minus of this is nothing but the generating function, so we can rewrite this thing. It is t minus x into Pn, or summations over n is Pn is a function of x into t power n is equal to 1 minus 2xt plus t square into summations n is equal to 0 to infinity Pn into n into t power n minus 1. Okay, so just now just multiply with the bracket with these polynomial things. Okay, so here if I multiply, so these things is t into summations, or I'm directly right here, summations n is equal to 0 to infinity Pn is a function of x into t power n plus 1, okay, minus x into summation n is equal to 0 to infinity Pn is function of x into t power n is equal to, and these things summations n is equal to 0 to infinity Pn into x into n t power n minus 1, and the minus 2x summations n is equal to 0 to infinity Pn into n t power n. Okay, and the last term, that is plus summations n is equal to 0 to infinity Pn into n into t power n plus 1. Okay, so this is, we have the now expressions. Now if I equate the coefficients of the t power n, so for that we need to put here n is equal to n minus 1, then we get the t power n, and here is as it is, and here n plus 1, then we get the t power n, and here that is t power n minus 1. Okay, so if I put p n minus 1 into t power n minus x Pn t power n is equal to Pn into n, so here Pn plus 1 into n plus 1 into t power n minus 2x Pn into n t power n, and the last term, that is p plus Pn into n, Pn minus 1 into n plus 1 into t power n. Okay, so now if I equate the coefficients of the t power n, okay, then we get this relations, that is n plus 1 into Pn plus 1 is function of x is equal to 2n plus 1 into x Pn x minus n Pn minus 1. Okay, so this is a second property of the Legendre polynomials. Okay, so stop here, we will discuss in the next lecture.